6 questions.
You have to do it twice. Doesn't read
That
the
makes
first one.
sense.
It has to be wrong.
That looks like B question.
Shh.
Looks like queso.
6
Quest.
quesotons. 2 non calculator. And I'm not gonna write down 4 calculator because I'm hoping you can do 6 minus 2.
See, this is
Okay.
why.
Fine.
You never know. I mean,
What?
You're gonna forget.
We're talking kids, right?
I don't care if you can't do 6 minus 2, you should read calculus. What is that? Never mind. Just, okay, let's get
It
to
looked
what
like
the
a B.
questions are now. Okay, so those are the questions.
You can always just punch a new page.
Okay, we'll do that next time. I don't have as much experience as you, Dr. Fawcett. Okay, so the first topic.
Okay,
Listed.
relative and absolute extrema.
So extreme.
We know the extreme, relative, and absolute.
On a graph or an equation, but
Yes.
okay. From graph and equation.
Okay, so difference.
In other words, you're going to have to be able to pick out the difference between relative and absolute.
So you're gonna have to know the difference between relative and absolute.
Give me this so I can show an example because this one might not show what it.
Where's the mic for this hat?
It's on my computer.
Oh. Okay.
So, for example, on this one, your absolute minimum is here, absolute maximum is here, relative is here, relative is here.
So the
I guess depending on your interval.
Okay, so the next topic is actually finding extrema on an interval.
you said this for
No, we haven't been page
exactly
one
what
of
you
these
scroll
buttons.
down.
It's the one that's got on the bottom left.
Bottom left.
It's got a big old plussy thingy.
Oh, that would make sense. Okay. Next is what now? Finding
Extrema on an interval.
horribly. Extrema on.
Extrema.
Yes, that's right.
It's extreme.
Extrema.
It's extreme. Extreme.
It is extrema. Interval.
Hey, look how big this file is.
So to do this, you're going to have to find critical points.
Find critical points. Maybe I should repeat what he said so they know what
They can find you would find critical points and test on each side, right?
And test the critical points and the endpoints.
Find
Find
critical
maximum
points
and
and then test crit points and the endpoints.
Critica.
and the endpoints.
Okay.
Yeah.
What
Sounds like-
example should I use for this? Think of an equation that looks like somewhat this.
Okay, g of x equals
Big page.
And here's an example.
2x plus 5 cosine x.
That'll give us. Okay.
On the interval 0 to 2 pi. Closed interval. Which means you have to test it.
Remember, if it's an open interval, you don't test your endpoints. If it's a closed interval, you do. Okay, so first you would find the derivative of this thing. What the freak is that? Okay, that's a 5. Okay, so you have 2 minus 5 times the sine of x. Now you would find where this is equal to 0. Move 2 over.
see.
No, but
I didn't think so.
this knows that it doesn't.
Yeah, I'll go to capital.
X equals.
It's not a nice one.
How sensitive is
R
it?
sine of 2 feet. Point 41.
What?
0.41
Point
radian.
4 1.
Radian.
Isn't it the little?
You know what units you're assuming.
Is it the R or is it the
You can just
theta?
leave it. It's just leave it with that.
Radians.
So now you would check. You would draw your little graph thingy. Am I right? You put the plot, the endpoints in that, and you would check on each interval. Right? Or not?
Yeah, you're missing the point, the critical point. No sign.
Huh?
Draw a sign.
Draw sign. Wow. Oh wait. There's sign.
No, wait, never mind.
Oh.
Okay.
So
Yeah. Alright, so then you plot your graph, plot endpoints, and then critical point, and you test each other. So, to do that, you have your 0, 2 pi, and I don't have a clue what 0.41 is.
You divide it out
By.
pi, and you divide pi out, right?
Oh. I kind of look like
You divide the pi out of that, you get that number. So how would you put it back in pi?
0.415
And you multiply that by pi, you get that number.
by 5 pi.
No, multiply 0.41 times pi.
Mm-hmm.
That was actually
Isn't it 4 pi? This is gonna be like a 50.
1.3. Huh? 1.3 is what I got.
Okay.
So that's like less than half pi.
Really?
So yeah, just like it right there. So now you need to test each interval. You need to test this interval here, this interval here.
No,
I mean,
not intervals, points.
a point in this one, right?
No.
No, wait, it's just the points on
Your
this.
critical point and your endpoint.
Right.
So is
And
it
you
0
get-
and 2 pi?
And that. So 1.2. So 1.2 is going to be right here. That's your critical point. 0 is going to be sine of 0 is 0, 2. So 0 is going to be up here. And 2 pi, still 0, it's going to be up here. Huh?
Oh.
Right.
Yeah.
Okay. So then your relative maximum and minimum is your maximum is going to be 0 and 2 pi, right? Because they're both 2.
Mm-hmm.
You said we're not gonna. Is this something that we'll get, or is this more complicated?
You'd have to have a calculator. You could do it.
I think you one that works out more the key angles on the non-calculator.
Then you would.
And probably,
So would there be a minimum?
mm-hmm.
That your critical point minimum is 0.41. That's how you do that.
I'm confused. I'm pretty sure it would be 2.
You
You don't have to
get-
plug anything back into the.
You plug it back into the original.
Oh, correct.
You plug it back into the original.
See, come on, Anthony.
Remember what you're doing.
Let's see.
2x plus
So the original was 2x plus 5 cosine x. So it's x 0 is going to be 2, cosine is 1. So 5, 0 is 1. 0 is 5, which is up here. 0.41. 5.4 on 0.41. That's not a critical point.
No, I thought it was.
This is 5.4, which would be your critical point, and then 2 pi is 1 pi. Again, is
These are completely different clues.
5.
What?
4 pi plus 5.
Or pi.
That's a really hard one for this, which is about 17-ish or higher, which would be way up here in this area.
Approximately.
So,
Exact answer would be 4 pi.
which is way up here. So, your maximum is going to be 2 pi. Is it just 2 pi and 0?
What was the value of 0?
5.
Is that the biggest value?
Nope.
Then that's not a maximum.
No, it's your minimum though.
I don't know, you're gonna have to go and get it from 4 down.
5.4
And that would be the
minimum.
minimum.
And your minimum is 0. So your critical point's nothing. Well, I
That
mean,
was your critical.
I thought it was 4.1
Well,
pi. Or 0.41 pi.
It would be relative.
Just
oh,
really
yeah.
big.
Right. Next topic,
Rawls theorem.
Rawls theorem. You spelled Rawl wrong.
It's
Two
okay.
R's. Okay, so first thing, remember Rawls theorem is when you check on an interval if there's an x-intercept or not. And for that, 2 conditions have to be present, which are
Continuous on closed interval.
continuous on the interval given, and
Differentiable on the
Yes.
open interval.
continuous and differentiable.
Continuous on the closed, differentiable on the open.
What's the different?
But that's not what
Stupid
it
word.
is. What the?
Differentiable. This isn't English class.
Continuous on a closed interval.
Mhm.
This is on the closed interval, and this is on the open interval.
You could barely even read that.
At least I spelled it right. Anyway,
This looks like
you
an
have to
R.
check both of these, otherwise it does not work. So, what? Give us an example.
So, yeah. Now, if we're dealing with an open, with an interval AB,
Open or closed?
it's gonna have to be closed interval.
Okay.
So if f of A equals f of B, and this is the third condition.
This is the third condition. If f a equals f b,
And somewhere you have a critical point.
then somewhere between a and b there is a critical point. So, give us an example.
Or your derivative equals 0.
Yeah.
Okay. Okay.
There we go.
So,
Okay, f of x equals,
For example, f of x
Equals
x squared minus 2x.
x squared minus 2x. What interval?
0 to 2.
On the interval 0 to 2. I don't know why I wrote that wrong.
It would be a closed interval.
yeah, he's
Okay, it's 0 to 2. I wrote that wrong. So you test your function values.
But first you have to come with
Okay.
everything that's continuous and differentiable.
First,
On that interval.
if it's continuous, you know it is because there would not be an asymptote or a cusp because this is a quadratic and there's no special conditions. It is differentiable because it's a string.
So negative texture.
So now you test if f of a equals f of b. So x squared, which is 0, minus 2x, which is also 0, is 0. Oh, you have to write it down. Go ahead.
Wait, why is it 0?
If you put 0 in the x,
Oh, okay,
then you
my
get
bad.
0 minus 0.
12
Yeah.
and a half
F is 0.
equals 0. And then f of 2, 2 squared is 4, minus 2 times 2 is 4. 4 minus 4 is 0. So since they're both 0, this
They
they're
want you to find then where the critical point is.
So now we have to find the critical point. You know there one exists now.
Mm-hmm.
You derive this,
How do we derive that?
2x
How do you
minus
find
2.
critical points?
Shut up.
Set that equals 0. It's 1.
Oh, my God.
2x minus 2.
There you go.
This is why you shouldn't be a teacher.
Why should we?
Because you, like, go...
Nobody answered you quick.
That's the whole point of teaching.
Okay, so that's our critical point between the interval 0, 2.
Okay, that's the point of that.
And that is your answer. That's all I have to find?
Yeah. I'll tell that to go on that stuff.
Alright, next.
Mean value term.
Mean value theorem. Again.
Mean...
This is the multiple continuous differentiable. Find the average, rate of change, and somewhere the average constant number to be equal.
So this again, you have to be continuous and differentiable. It's like the last one. Example.
X to the 2/3. That's
You started out with a fraction.
2/3.
Well, you did.
The closed interval is 1 and 8.
And we're finding the
You want to find the point where the instantaneous equals the average.
how do you find average?
That's the secret.
Alright, so first you find the secant line by
It's algebra 1.
I know.
No. Plug into the original.
Plug in. Okay, so you plug in your endpoints to that. 1 and 2.
No,
I mean 1 and 4.
What?
No, 1 and 8.
No, I'm plugging with the answers. I'm not going to do what you put in.
It's 1 and 8.
Yeah.
Oh, this one 8.
Cube root 8 is 2 times squared is 4. It's 1 and 4. Right.
You said 8.
No, it's 1.
There's a function of how you find the slope and you've got 2 x's and 3 y.
Point slope.
No.
You said the slope.
That's overrun.
Oh. 4 over 1?
No.
No.
But
So on this, you're going to do rise over one, run. These are your y values. These are your x values.
oh, I got this.
Okay. Now you can take.
It's algebra 1. This is algebra 1.
4 minus 8 over 1 minus 1.
No.
That's
What Where did you put your X's over your Y's? You got slow dyslexia? You got slow dyslexia?
What do you mean X is over the Y's?
It's y.
It's Y1, okay.
This times this. Sorry, Dr. Foster, I apologize. Which is 3/7.
Oh,
Now
yeah.
you find a point where your derivative equals 2/7.
So first we would find our derivative, which is 2/3 x to the negative 1/3.
Negative.
Huh?
Oh, yeah. My bad. I'm dead.
X to the negative 1/3.
You set that equal to your derivative.
Equals to 3/7.
And solve. And solve.
Okay, so first thing you're going to do is divide by 2/3. One second.
Let's get the times.
What about 3 times?
You never divide by a fraction.
Okay, so 9/14. Which does that produce? You sure this works out nicely? Cube them both. Let me cube 9/14 real quick. I probably could do it in my head, but I don't do it. It is, I wanted a fraction. This calculator doesn't do that, does it? You cube the top and the bottom separately, right? It's 729 over 2744. I'm sure that reduces. You would think. Oh, it's the 9. Okay, maybe.
Actually, you can put it in your calculator and see if it goes forward.
The other piece.
Not a little bit forward. But that can go to that.
Now it doesn't reduce.
That's the point.
Okay. Do you want it like that or this? And you just leave this like this because it's exact, rather than change it to decimal. And that's Jonathan's handwriting. All right. You can go and start a new page. Next.
I hope they watch
First
this.
derivatives, first derivative test.
We say if you're going to find the first derivative.
First derivative test for extreme, for algebra extreme.
This is where you get your points and check into it. See, I'm just waiting.
Yeah, figures.
Alright, this is where you would find your critical points and you test on each side of your critical points to find if you have maximum.
Okay, so here's your function, ready?
Yep.
1/4 t to the 4th minus 8t.
8t.
Oh, 8. T.
T.
Alright. So you would, to test for extrema, first, oh wow, you made that nice first.
Yeah.
First, you find your first derivative, which is t to the 3rd. Don't question that. Minus 8. So now you set this equal to 0. Wow, you are so nice. Which it's 2.
I like to do this too.
This is the kind of thing that we do on the right.
Good. It was very nice. So this is your critical point. Do we need to?
I want to use the first derivative to find relative extreme.
Okay. So what you're gonna do now is you're gonna find out. Give me the freaking marker.
It's not a marker. You just grab another one.
It won't work. No.
Which means you have to figure out where it's increasing.
Right, so now you draw your graph. So you have your point 2 here, and you test it on each side. So we'll pick a point here, 3, and we'll pick a point here, 1, and that goes to your original. No, wait.
I'll figure it out.
That's what I meant. I don't know why I picked 1. Does that go to your original function?
Your original. No, your
It
first
is
derivative.
derivative, okay.
First derivative.
So,
you want to figure out whether it's increasing.
right. So we'll plug 0 into t cubed minus 8, which is negative 8. So this side's decreasing. And we'll plug 3 into it, which is 1. So it's not 1, it's 27. Minus 8. It's 19, so it's increasing. So if you're going from decreasing to increasing, you know you have a relative minimum. So 2 is a minima, or minimum. What do you
Okay. That's it.
Alright, that's 5 when you want to do it. And compressing these things takes up a lot.
Second derivative test.
This is where you test for concavity and
And you can also second derivative find the second derivative.
oh yeah. This is when this is the same thing basically, but you're testing for concavity rather than extra. So
X plus cosine x.
okay. So we're gonna derive this. So the second derivative is going to be negative cosine of x, and we set this equal to 0. Would this be on an interval 0 to 2 pi? This will be on an interval 0 to 2 pi.
They don't tell you otherwise. It's trig functions are going to be on 0 to 2 pi.
So just repeat after that.
If this is like a negative cosine and you move it over here, would it still be arc cosine, or would you plug in normal
Why would you move it over?
to divide it to find x? Or is it this one?
No, you're finding 0. You set this equal to 0,
That's what I just did.
which wouldn't matter. Cosine is 0 at power 2 and 3 power 2. In case y'all didn't know that.
This would be a good non-calculator.
Pi over 2 and 3 pi over 2 are your critical points. So then you would put these on a graph and you would test your intervals on each other. Alright. Draw a graph of cosine. Oh wait, no, we need the original graph, don't we? The x plus cosine x.
We're doing the second derivative.
Oh, so no. Wait, we do need the original graph, but we plug the numbers into the second derivative, right?
Yeah.
So do I need this?
No. We just need a graph with power of 2 and power of 2.
Okay, now what we saw for the second derivative, those are critical. Tell me those are points of inflection. None said critical.
Once you plug these back into there.
You still have to use the first derivative to find critical points.
You do? And what's this for then?
Huh?
What?
Okay, those are points of inflection. That's your category.
Okay. And what are we supposed to find in this problem?
Extremely, what you're going to be at the critical points.
Okay.
You still have to.
So 1 minus sine of x, you need that equal to 0 too. Which is, pi over 2 and 3 over 2.
You do know it's negative one, right?
Well, we know what that is.
We're solving for x.
Yeah, it's negative 1, but they're both negative. Which would sine equals 1. sine equals 1 at pi over 2. It just equals 1. Pi over 2.
X equals pi over 2?
Yeah. Okay, so then that's the first one.
You can grab them all for the point person. No, bro. Science one.
Yeah.
Okay.
So now what do you do with this information?
That's your critical point.
So you test
Now you need to figure out whether it's in
maximum. So you would, on a graph, you would plot pi over 2 and test each side. So just plot pi over 2.
No, actually, I just put it on the
So it's the sine. That's a
second derivative.
So the second derivative, you plug pi over 2.
What if it's, what does it tell you if it's positive?
Then the concave.
Which means that it
If you plug in pi over 2
Concave
to the
down,
second
so
derivative, it makes it 0.
Yeah,
what
pi
if
over
it's
2.
points of inflection?
Pi over 2 makes it 0 because it was a critical point. So you would test it on each side?
No, because at that point, that's your critical point, right?
Right, but I'm saying if you test it here, then this is, the second derivative is equal to 0.
You plug in the point, okay, second derivative is equal to 0.
At the critical point.
Okay, so what that means is the second derivative just fails.
So, okay, so yeah, if you plug in the point you get on your derivative, first derivative and the second derivative, and you get 0, then the second derivative test fails.
And then you have to fall back on the first derivative.
So now you use the first derivative test to find it, which you would, again, you would plot on each side of this, here and here.
But always put the critical point in and see what happens.
So sine of 0 is 0, and minus 1 minus 0 is 1. So this side's going to be positive because you get 1 as your answer. Other side, what's easier? No, pi. Sine of pi is 0. 1 minus 0 is positive. So they're both positive. Or did I do some math wrong? Yeah, it's 0. Yeah, I got positive on both of them for the first. You plug these into the first derivative, right?
Mm-hmm.
So, yeah, first derivative.
Right.
So they're both positive. Sine of 0 and sine of pi.
So it's been positive, which means you're increasing, right?
Yeah, which means you're increasing and still increasing,
So
still.
what does that mean?
Does that mean this is a point of inflection? So you
So
go like,
you have a relative minimum.
yeah. So
So you have, is that a relative minimum or maximum?
right here,
Mm-hmm.
neither is it. Yeah, it's nothing because it's to the point of inflection, so it's going to go concave down,
No,
and then it's going to flip and go concave up.
no,
But it's still increasing.
no. And then the last thing is curve sketching. Using the first derivative, second derivative, x and y intercepts critical points. That's what that last 20% was.
Yeah.
And this will be one of them without calculator.
Alright, this will be without the calculator, and it's going to be curve sketching.
What?
So, I'm going to give us a function, and we'll try to graph it.
Yeah.
What do you think? This is just not the voice. This does the division. Speak.
X plus 4 over x.
Well, it's the whole thing over x, or just the 4?
No, x plus and then 4 over x.
Alright, so first you would, okay, so first you'd find your x and y intercept, right?
Yeah.
Alright, so you have x intercepts and y intercepts.
Maybe.
Maybe. So to find your x-intercepts, you set this y equal to 0, right? So this would, you'd set this equal to 0, which is
Gotta look at X out of the mind.
right. So x squared plus
I'll get x squared.
you multiply the other side, multiply all of this.
I'm gonna beat this x to negative 1. What? What are you talking about? Oh, if you're moving it
Saying
up.
get
from
rid of the x like out of the denominator. So you multiply the equation by x. So you have x plus x squared plus 4
Equals.
x. No wait, never mind. Yeah. So negative. Oh wait, there's not an x.
plus or minus 2.
2 squared plus 4 is 0.
Which is solving for x.
Yeah.
And this curve would have negative.
So no x-intercept because that doesn't exist. Now you find your y-intercept. You set x equal to 0. So can you use this x squared plus 4? I guess use the original. Is it undefined?
That's a what?
Asymptote. So at
Vertical asymptote.
right, so y-intercept is vertical, has a vertical asymptote at 0.
No, we don't have one.
Yeah, yeah. The y-axis is a vertical asymptote. All right. Next, you need critical points. So we derive this.
The original.
Yeah.
And this is where we write it later on.
Yeah. So your derivative is going to be 1 plus 4 times x to negative 1. So negative 4x. Negative 4x. So negative 2. So 1 minus 4x to the negative 2. I don't know.
Over x squared.
Over x squared.
Over x.
Oh yeah, either way. Yeah.
Why did that way? It makes it a lot easier.
Right.
That's equal to
0. So your critical point is going to be at 2 and negative 2.
what? Really? Yeah.
You have to tell y, it doesn't say.
That equals 0. You square 2 or negative 2, you get 1 minus 4 over 4. 4 over 4 is 1. So critical
This is
point.
y.
Alright. So now you have, you test,
You can find increasing, decreasing, and comparative.
okay, so which one would be better to do first?
Oh, at the first derivative, no.
Yeah.
So what do you think would be better to do first?
Well, I get the second.
It doesn't matter.
Okay, so we'll get the second derivative now, which will be,
But you still have to figure out increasing and decreasing anyway. Which you get from the first derivative.
right, you plug it on different sides.
Mm-hmm.
So we have 1 minus 4x squared. To derive that, it would be
Yeah, 3.
8x to the 8 over x cubed. Right?
Mm-hmm.
So we need to set this equal to 0, which is just 2.
No.
No, it's not. You can't set that equal to 0. So there's no points of inflection.
No.
You can't set it equal to 0. Okay. So now we'll draw our graph. Kinda.
Zero, I'll slap you.
At least I didn't set 12 equal to 0 like Kelsey did. That's illegal. Okay. Okay, so we have 2 and negative 2. Should have done it. Alright, so
Hilarious.
I can already tell you what this is going to look like. Anyway,
Yeah, and then you
plug in a
gotta
point.
get increasing and decreasing, so you plug in the first derivative, you plug in the second derivative, you get comparative.
Yeah.
You find what your maximum, what your Y values are, the critical points, then connect dots.
Alright, so now you test for increasing, decreasing. So this is into your derivative, right?
You do both, yeah,
This, and this.
for your first.
Alright, so these going 4 points from these sections go into your first derivative. Which
You only
is,
have to, yeah, because you're gonna have.
yeah. Because this is an asymptote right here, you have to check both sides.
Yeah.
So, let me do this really fast. 1 minus 4x over x squared, we'll do, alright, 3. 3 squared is 9, 4 is 9, it's 4 9, so it's positive. 1 minus 4 is negative. Negative 1 squared is 1 minus 4. This is positive, and negative 3 squared is 9 minus 4 is positive. Wait a minute, I did something wrong there. That's alright.
Not necessarily.
Oh, sorry, it should be negative here. There we go. There, that's negative.
And then you need to find your Y values at each one of these, which will give you a point to hang on here, right?
Find your y values at 2 and negative, or
Yeah,
2 and negative 2, which you plug in your original.
original function.
Okay, so what are our original functions?
4 plus 4 over x.
X plus 4. Original function was x plus 4 over x. And we plug in 2 and negative 2. 2 plus 2 is 4. So you point that.
Mm-hmm.
We're going to say this is 4. And negative 2. 2 plus
I don't even think this is
negative 2 is 0.
No,
You plug in negative.
negative
Oh,
2
negative
minus
2
2. It's a
minus-
negative 4.
It's negative 4, so it's going to be down here. And it goes increasing to decreasing, so it's going to be up and down, right?
Mm-hmm.
It's going to look like this. And this one's decreasing to increasing, so it's going to look like this.
Yeah.
And that is what it looks like, and the delta string. So, good luck, guys.
Yeah, press that, and I'll